Okay, hi folks. We're going to talk about a couple things today. We're going to talk about variables and we're going to talk about causation and how we apply the scientific method to sociology. Now, you're going to take the formative and then afterwards there's a short worksheet where you work with variables. So that's due for next time. So you're going to apply the things we talk about today for next time. Now, a hypothesis is an educated guess that you make before you do an experiment, before you do research. And it articulates the relationship between two or more variables. We will talk about independent variables and dependent variables today. And what you're doing with the hypothesis is you're predicting the research outcome. At the end of class, you're going to watch the blue eyes, brown eyes experiment, also called the class divided. One of the things I want you to think about as you watch it is, what are the variables here that Jane Elliott, the teacher who's running the experiment, is manipulating? So when you carry out that research, in this case, when you do the experiment, you're testing the hypothesis. If you pay attention during the video, she predicts beforehand. So she lays out her hypothesis ahead of time. And then pay attention to see if her hypothesis is borne out through the experiment. Does her prediction prove correct? Back in Unit 1, we talked about Auguste Comte, the guy who came up with the idea of positivism, being positive through observation of the physical world in sociology to make it more like a science. So sociology tries to follow that scientific method. Okay, causation. There's a basic premise or assumption in science that the physical world is predictable, and that if there's an effect, there was a cause. And sociologists apply that to the study of society and groups. The thing to remember is that many times there are multiple causes for an event, not just one. So, for example, if we look at an issue like poverty, can we explain poverty by one variable or one factor? No. There's all kinds of different variables that play a role in explaining why there's poverty in society. Maybe it's poor education systems, maybe it's the lack of intact families, multiple variables. So that's a key point to remember. Okay, let's dig in a little deeper with variables. So variables, we're talking about an element that you identify in your hypothesis that varies in quality or magnitude. So it must have at least two levels, two or more. There are quantitative variables, so that's going to produce a number at the end. So an example of that would be like if you were doing a survey, the number of students who leave campus for lunch. Let's say you were doing a study about lunch habits of students. And actually, since we have closed campus, this one doesn't apply anymore like it used to, but you get the idea. That's a quantitative variable. Then you have qualitative. Usually this is a yes or no or an either or. So for example, take that survey again. Male or female would be something on that survey that would be a variable, and because it's non-numerical, it's a yes or no or an either or. In this case, we're talking about a qualitative variable. And then finally, variables must be identified as either independent or dependent. Think of independent as the cause, dependent as the effect. So here's an example. This is an independent variable. Let's look at this statement. Aging leads to loss of memory. Aging would be the independent variable because it's the cause. Loss of memory would be the effect. So that would be the dependent variable. Independent variable is the cause. Dependent variable is the effect. So the sheet that you're going to work on in a little bit, when you read the statement, identify, first thing to ask, what is the cause in this statement and what is the effect? and then line that up. Cause is the independent variable, effect is the dependent variable. So this is the variable that's manipulated or varies. In the Milgram experiment, one of the things that was varied was manipulated, right? If you think back, the students sometimes, right? So some of them had a heart condition. What was said to the teacher was manipulated by the expert who is sitting behind them, and so forth. So anything that is varied or manipulated, that's the independent variable. Okay, so the dependent variable, that's the effect, that's the result. That's the thing that the hypothesis describes, explains, or predicts, that there will be changes in it, that it will result in changes. So it's the variable that is influenced or changed by the independent variable, excuse me. If there is a change in the dependent variable, there necessarily has to be a change in the independent variable. So if you look again at that statement, again, aging causes a loss of memory. The dependent variable would be loss of memory. Okay, so take a look at the statement. Matthew placed his bike in the driveway day after day until his father finally became frustrated in having to move it and sold the bike. If we look at that statement, the independent variable would be Matthew placing his bike in the driveway day after day. The dependent, the effect of that is that his father finally becomes frustrated and sells the bike. So father selling the bike would be the dependent variable because it's the effect of Matthew placing his bike in the driveway day after day. Okay, the second one. Gina tried various online dating websites until she finally found one that produced a long-term relationship. Okay, if we look at that statement and identify the cause and the effect, the cause, the independent variable, would be Gina trying various online dating websites. The effect of that would be she finally found a long-term relationship. So long-term relationship, finding a long-term relationship would be the dependent variable because that's the effect. And then finally, Rockfest posted its best ticket sales since before the Great Recession. Okay, now this one is switched up a little bit, right? So if we look at the cause and effect, the cause in this case would be the state of the economy. The effect would be best ticket sales since the Great Recession. Did you get that? So think about that for a second. The effect is the better ticket sales. The cause of that is better economic times. So back in the Great Recession 10 years ago, when the economy was bad, ticket sales were worse. So the independent variable here is the state of the economy, and the effect is ticket sales. Okay, now let's talk about correlation. Correlation just means that there's a relationship between two variables. That's all it means. It does not mean causation. It doesn't mean one of those variables is necessarily leading to the other. So if you have a positive correlation, that means both the independent and the dependent variable change in the same direction. So for example, the heavier the barbells you lift, the more muscle mass you gain. So both those variables are going up. Negative correlation is when the variables change in opposite directions. So here's an example of that. The fewer, so that arrow is going down, the fewer hours you spend playing video games, the higher your GPA increases. So in other words, that variable, the dependent variable, is going up. So there's a negative correlation. The independent and dependent variable are going in opposite directions if you were graphing them. Now, sometimes you get a spurious correlation. That means there's the appearance of a relationship between a couple of variables, but it's actually caused by a third variable, a hidden variable. Now, if you look, let me open up this website because I just think it's cool. This math student in college went out and looked at data, and he came up with all these crazy spurious correlations. So there appears to be a relationship between the variables, but there really isn't. So like this first one, he found what we spend, what the federal government spends on science, space, and technology, and he matched that up with the variable of suicides by hanging, strangulation, and suffocation. And you can see, if you didn't know any better, if you just looked at the graph, you would think, okay, well, there's a relationship between those two variables. But obviously, the amount of money spent on science, space, and technology doesn't have a relationship with number of suicides by those different things. Or look at this one. Here's an even more ridiculous one. So he looked at the number of people who drowned by falling into a pool, which is actually more than you might imagine. And then he looked at the number of films that Nicolas Cage appeared in, and he saw that look at the variables, how they move in very similar directions. Is there really a relationship between number of people drowning in pools and the number of films that Nicolas Cage appears in every year? No. You can see there per capita cheese consumption compared to the number of people who died by becoming tangled in their bed sheets. Again, it's very close, right? But there really isn't a relationship between those two things. Age of Miss America compared to the murders by steam, hot vapors, and hot objects. I didn't even know that there were murders by steam, hot vapors, and hot objects, but apparently there are. And if you didn't know any better, you would think, okay, looking at those variables, there must be some kind of connection between the age of Miss America and murders by steam, hot vapors, and hot objects, but there really isn't. Number of people who drowned after falling out of a fishing boat compared with the marriage rate in Kentucky. Japanese passenger cars sold in the U.S. compared to suicides by crashing of motor vehicle. Letters in the National Spelling Bee compared to the number of people killed by venomous spiders. Terrible way to go. Again, on outward appearances, it would look like there's some kind of relationship, but there really isn't. That's a spurious correlation. Okay, causation means one thing, one variable leading directly to another. And you got to know this right here. These are the three standards to show causation. I always have a question on the test asking you, what are the three standards? So make sure you memorize these. First thing is, and by the way, all three standards must be met to demonstrate causation. First of all, the two variables must be correlated. Second of all other factors must be taken into account. So in other words, you've ruled out multiple causation or spurious correlations. And then finally, if there is a change in the independent variable, there necessarily has to be a change in the dependent. So think again, cause and effect. Finally, for that test review response, if you look at these two examples and try and pick out, is it causation or is it just correlation? So the first example, the Democrats have won a higher percentage of presidential elections since Milky Way overtook Mars as the second most popular candy bar in America. Is there a causal relationship between those variables? No. Just because there's a Democrat winning a presidential election, that would be the dependent variable. Does that have any causal connection to Milky Way becoming more popular than the Mars bar, which would be the independent variable, the cause? No. But if you look at example number 2, raising of speed limits by 5 miles per hour and increased texting while driving resulted in 10 to 15% increases in highway fatalities across all 50 states over the course of 10 years of studies. There we probably do have a causal relationship. So when you raise the speed limit and when more people text while driving, so those would be the independent variables, the causes, it results in 10 to 15% increases in highway fatalities. That would be the effect or the dependent variable. There probably is a causal relationship. Okay, do the formative number 1 for unit 2 on Canvas, and then after that, work on the variables worksheet, and then the last part of class, you'll watch the Blue Eyes, Brown Eyes, or a class divided video. I'll see you next time.